this video is to go along with the Edgenuity lesson, triangle similarity, side, 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 and side angle side. So in this lesson, we learned two new, sorry, I thought my computer froze. In this lesson, we learned two new similarity theorems, triangle similarity theorems. In our last video, or the prior Edgenuity lesson, we learned about AA, and what that told us is if I just know that two of the angles are congruent, these two triangles have to be similar by AA. That's all you have to show. If you can show two angles are the same, or excuse me, two corresponding angles are the same, you're done. The triangles are similar. The first one they talked about in the lesson, I believe, was side, side, side. And for side, side, side similarity, you just have to show that all the sides are proportional. So let's say we had 6, 6, 4. Okay. What would happen is when we write out the corresponding side lengths here, so their scale factors, so 6 corresponds with the 3, it has to equal 6 corresponding with the 3, which has to equal the 4 corresponding to the 2. So if I simplify all of these, I get 2 equals 2 equals 2. That means the sides are proportional. If it doesn't match up, if I got 2 equals 4, these are not similar triangles. And again, that's for the SSS similarity. This is angle similarity. The last one that we've learned so far is the SAS similarity. And what that is the two sides are proportional and the angle in between them is congruent. So again, it has to be the angle in between the two sides. So for example, if I knew that this angle was the same as this angle, it would have to be these sets of sides proportional. Just to make it easy. So again, I know that these triangles are similar because if I simplify these two ratios, again, I get 2 equals 2. And if you have that angle in the middle, you're done. So there are 3 choices now that you can use to prove that triangles are similar. So looking at this first example, is triangle RST similar to triangle PSQ? If so, by which theorem? So just so that we have an idea of what we're looking at, triangle RST is this one in the top, and triangle PSQ is this whole thing. So the pink triangle is sitting inside the blue triangle. So first, let's look at their side lengths. So as a reminder, if the side lengths are not proportional, we're already done. So the side length of SR corresponds with the side length of SP. So don't let them trick you here. It's this whole length here, so 16. Then we also have information for this side where ST is 5 and the whole length SQ is 20. So these have to simplify to the same fraction. If they don't, then the side lengths are not proportional. So if I simplify 4/16, that's going to simplify to 1/4. Divide the top and bottom by 4. Here, if I divide the top and bottom by 5, I also end up with 1/4. Okay, so that's great. Unfortunately, we don't have any information for RT and PQ, so I already know I can't use side, 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 because I only have 2 of the sides. So the other theorem is the SAS. Well, if you notice, both triangles are using angle S, and angle S has to be congruent to itself by the reflexive property. Oops. By the reflexive property. So therefore, triangle RST has to be similar to triangle PSQ by, this one is SAS. By SAS similarity. One more. Is triangle DEF similar to triangle ABC? And then I'm going to have us go ahead and name which theorem it is if they are. So remember the order of the similarity statement helps you know which parts correspond with each other. So DE, because those are the first 2 letters, are going to have to go with AB, because those are the first 2 letters. And then EF has to go with BC. And then the last one I'll just leave blank because obviously those ones have to correspond with each other. So just to mix things up, I'm going to go from right to left on this one to set up my statement of proportionality here and see if they all work. So the first scale factor is 2, 6. 3 corresponds with 9. And 4 corresponds with 12. So let's see if these are equal. 2, 6 simplifies to 1/3. You just divide the top and bottom by 2. 3/9 simplifies to 1/3. Okay, so those ones are good so far. 4/12, if we divide the top and bottom by 4, we also get 1/3. So since they all simplified to the same ratio here, that means, yes, triangle DEF is similar to triangle ABC. And this one is by side, side, side similarity, because the 3 sides are proportional. When you simplify, you get the same ratio. If, for example, we've gotten 1/3, 1/3, 2/3, then it would be no, these triangles are not similar.